Hi, I'm Whit Vernon with another training program from the Ford Parts and Service Division. Our subject today, how to test the 1981 MCU system. Bill here is going to assist me since he knows his way around the MCU system. First, let's run through the test equipment needed for functional testing of the system. One thing for sure, some critical readings are required to help solve MCU problems. The analog voltmeter is a must to get those correct readings. This particular model is also a tachometer capable of detecting a change in engine speed of 20 RPM or less. And if you have the digital readout tester, you can use it in place of the analog voltmeter. You'll also need a vacuum gauge, jumper wires, and a timing light that can be adjusted to reveal true advance. Plus, of course, a set of conventional hand tools. Next, Bill is going to identify and show the location of the components that make up the MCU system. The vehicle we are using is equipped with a 5-liter engine. The hood is off so that you can see what's going on in greater detail. The self-test connector, where you hook up the voltmeter or star tester, is located on the fender apron. On unitized bodies, it's on the other side of the engine. These are the zoned vacuum switches that monitor cruise, closed throttle, and wide open throttle conditions. The throttle kicker relay located behind the vacuum switches increases RPM for cold start or overheat conditions. The thermactor air diverter solenoid and the thermactor bypass solenoid control the thermactor air valve. The valve bypasses thermactor air to the atmosphere under prolonged deceleration or uninterrupted idle. The valve will divert the air upstream to the exhaust manifolds during warm-up or other rich fuel mixture conditions. Under normal engine operation, the air is diverted downstream through this hose to the 3-way catalytic converter. This secondary air completes the combustion of carbon monoxide and other unburned gases. An exhaust gas oxygen sensor is threaded into the rear of the exhaust manifold. It measures the amount of oxygen in the exhaust gases to determine a lean or rich engine operation. There are 2 coolant temperature switches. A dual temperature switch that senses both low and high engine coolant conditions, below 55 degrees and above 235 degrees Fahrenheit. The mid-temperature switch closes when the coolant temperature reaches approximately 128 degrees Fahrenheit. A canister purge solenoid valve opens on command from the MCU to purge fuel vapors from the canister. The feedback carburetor actuator, also called a stepper motor, varies air-fuel ratio according to the driver's demands. On the opposite side of the carburetor, you'll find the solo pot, which is a combination throttle kicker solenoid and dash pot. It adjusts idle speed in accordance with signals received from the MCU module. On some 5.8-liter engines, a knock sensor is installed on the intake manifold. It is used to retard ignition timing if spark knock occurs. Before beginning the tests, it is important to determine whether the vehicle is equipped with a knock sensor or not, because test procedures will vary. All that remains is the control center of the MCU system, the microprocessor control unit. It analyzes the information received to determine adjustments required for specific engine operating conditions. The module is electrically connected by means of a multiple pin connector to the sensors, solenoids, and switches. Each of the terminals and the wires that feed the multiple connector are numbered. One side of the plastic case is numbered 1 through 12, while the opposite side is numbered 13 through 24. Wiring does not feed all designated numbers. Some blanks are for alternate calibrations that require additional sensors or solenoids. If you suspect a bad internal electrical connection or your tests prove there's a high resistance or open circuit, the pins can be removed separately for inspection. First, release the 2 plastic arches. which are notched to lock them to the plastic case. Then lift the soft foam gasket from the pin end of the case. With small needle nose pliers, carefully pull out the red locking bar. Using a small screwdriver, push the plastic latch away from the metal pin. Then the wire and metal pin will separate from the connector housing. To reinstall, simply insert the pin into the proper connector cavity and push in so that the terminal snap locks into position. Then install the other parts carefully. With other types of connectors, their attachment to the metal terminals can also be easily checked. As shown earlier, carefully press the small plastic latch away from the metal terminal. As you're doing this, simply pull on the wire and the terminal will slide out of the connector. Here's an enlarged view of that same connector. Note that the wire is not soldered to the terminal, only crimped. Therefore, it's possible that the strands of wire may not make a good electrical contact. If so, replace the terminal. Now, if you want to check the on-the-car circuits easily, the flip chart provides wiring diagrams for that purpose. It makes it easier to trace wiring between components. Also, the flip chart shows you how easy it is to reach service codes when using the analog voltmeter. One set of codes is for the 2.3-liter engine, another for the 4.9-liter engine. And these are for the 8-cylinder power plants. They're also listed in the shop manual. Service codes are always a 2-digit number, such as 11, 12, 25, or 41, to name just a few. All service codes except code 11 designate a specific malfunction within the MCU system. Before Bill connects the voltmeter into the MCU system for the tests, I will use this simulated analog voltmeter to demonstrate how to read service codes. The first digit of the code is determined by counting how many times the needle sweeps across the face of the meter before the needle stops for a 2-second pause. For example, if the needle sweeps 4 times, 1, 2, 3, 4, the first digit of the code is a 4. Immediately following a 2-second pause, the service code continues. In this example, 1, 2, 3, 4, 5. Now you have the second digit of the code, a 5. The completed service code is 45. One more important point you must remember. If the MCU system has 2 malfunctions, there will be a 5-second pause between the first and second service code. As an example, let's say you first get a code 12. 1 needle sweep, then after a 2-second pause, 2 more needle sweeps. Code 12, right? Then, if after a 5-second pause, the needle once again starts to sweep 1, 2, 3, 4, 5. That's the first digit of the second service code, a 5. The second digit begins, a 1. This makes the second service code a 51. Of course, if you're using a star tester, 2-digit service codes are shown numerically. Operating instructions are provided on the back of the tester. Now, to determine what problems are presented by the service codes, the technician would refer to the flip chart. Code 45 indicates the thermactor air is always upstream. Therefore, the technician would concentrate on only the components, wiring, and connectors that are part of the thermactor air control system. Code 12 in the flip chart indicates incorrect idle speed. This may be caused by improper idle speed adjustment or a malfunctioning throttle kicker. Code 51 indicates an open high-low vacuum switch, which must be checked and corrected. The shop manual tells what action to take with all the service codes. For example, service code 12 refers us to test 8 to check for RPM out of specification. Code 45 refers to test 11 for a thermactor system check. Code 51 indicates test 4 is required to correct an open temperature switch. Performance problems encountered may not be the fault of the MCU system. Something else could be at fault. Therefore, visual checks are very important and must be made prior to any MCU tests. Do not shortcut them. For example, if you're faced with a no-start condition or poor drivability, such as stalling, missing, or surging, treat the problem as if the engine did not have MCU. Check for physical damage or poor connections at the spark plugs, high voltage wires, the ignition coil, and, of course, the distributor cap, rotor, and other components. For other poor performance conditions, you may have to check engine timing, the fuel filter, fuel pump, or other components. If everything appears okay, or you have corrected a fuel or ignition system malfunction, then continue your preliminary checking. Grasp each of the MCU system connectors and pull lightly on each wire at its terminal as a preliminary check to see if it's locked in place. Loose wires that are not crimped properly cause intermittent failures, which are difficult to find. At the same time, check all the connectors to be sure they are firmly engaged and locked. And if you suspect internal corrosion of electrical terminals, carefully unlatch and separate the connector for a visual inspection. If necessary, clean the contact surfaces of the terminals. Before connecting, use a silicone lubricant or a white grease to prevent corrosion from forming again. Malfunctions can result from scarcely visible corrosion on MCU connector terminals because the total signal cannot be picked up or detected by the module, sensors, and switches. Be sure the vacuum lines are routed and connected properly. A thorough check is required because improper routing or vacuum leaks can really give you problems. If you're not sure, refer to the emission decal for the vacuum schematic. Once the visual checks are complete, certain pre-check conditions are necessary. Now let's start the pre-test and see what must be done before connecting the voltmeter or star tester. Check the coolant level. If the engine is hot, let it cool down. If low, add coolant as necessary. And as the flip chart tells you, be sure the transmission is in park position, or if manually operated, in neutral. Set the parking brake firmly, block the wheels, and make sure all accessories are turned off. Start the engine. And while it comes up to operating temperature, check for voltage being delivered to the choke cap. This check makes sure the carburetor comes off the high cam and that the cold start enrichment fuel circuit functions properly. Then check the radiator upper hose. If it is hot and feels pressurized, turn the ignition off. Next, separate the PCV from the breather cap and turn the valve away from the cap. Then tee a vacuum gauge into the hose at the canister purge solenoid valve. It must be inserted in the hose that leads to the charcoal canister. While in that area, make another check to be sure the carburetor throttle linkage is off the high cam. Some 8-cylinder calibrations require a vacuum delay valve. If so, uncap the restrictor in the Thermactor vacuum control line. But remember to recap after the end of your testing. With all the preliminaries taken care of, it's time for the functional tests. The first phase of the functional tests requires the key on but the engine off. First, insert jumper wire clips into these two sockets of the self-test plastic connector in order to ground the test trigger circuit through the ground circuit. Attach one of the voltmeter leads to the battery positive post and the other lead to the self-test output socket. Set the meter to read the 0 to 20 volt scale or use the star tester. Turn the key on, and if the voltmeter shows a steady high or a steady low voltage reading with no sweeps of the needle, this indicates that you have no self-test output. Further checking is needed because something is wrong with a voltmeter hookup or within the MCU system. The problem could be either in the ground circuit or the battery feed circuit from the ignition switch or a malfunctioning canister purge solenoid. If all connectors and wiring are electrically sound and the canister purge solenoid checks out okay, then the no self-test output is caused by internal problems within the MCU module. All steps necessary to check out a no self-test condition are listed in the shop manual. Follow them closely and you'll easily pinpoint and solve the problem. After correcting this condition, retest to see if you now receive the passing code 11 with key on, engine off. One sweep, a pause of 2 seconds, and one more sweep. The service code repeats itself. 1, 1, code 11, which indicates the MCU system passed the first stage of testing. Then continue the second phase of diagnosis by performing the engine running test. First, make sure the radiator upper hose is still hot and pressurized. Then run the engine at approximately 2,000 RPM for 2 minutes. This will clear the system so that you will get accurate test results. Turn the key off. Then immediately restart the engine. As it idles, immediately check for voltmeter needle movement. The MCU on 8-cylinder engines will show 4 quick sweeps of the needle. These are not service codes. They are called initialization pulses. At the same time the voltmeter is pulsing, the vacuum gauge needle will show a small pulsing movement to verify operation of the canister purge solenoid valve. A third action takes place with a solenoid-actuated solo pot. The throttle must be opened slightly, then released, so that the plunger stem can extend and hold a higher engine RPM. This will verify proper throttle kicker operation. This is not necessary on carburetors that use a vacuum kicker, since the kicker is powerful enough to advance to the throttle automatically. Either type of throttle kicker should remain extended for about 1.5 minutes, at which time the kicker will retract and RPM will decrease. However, if there are no initialization pulses of the voltmeter needle and no increase in RPM, the MCU system is not self-testing. Refer to the shop manual for corrective action. Now, if you do get the 4 initialization pulses, there will be approximately an 18-second interval while the MCU system performs a self-test, at the end of which it will display a service code or codes. If you get a passing code 11, and it repeats itself, then you know all components of the MCU system are okay. The test is over and the problem is in some other system, not the MCU. In our first demonstration, the MCU system proved out okay. But let's go back to the key on, engine off test and see how a technician would handle service codes other than the passing code 11. If a service code of 51 is received during this test, the technician would again refer to the flip chart or shop manual for the cause of the problem. For 8-cylinder engines only, code 51 tells you that either or both of the high-low vacuum switches are open when they should be closed. Now, if you received a code 65, that would indicate that the mid-vacuum switch is closed when it should be open. With either code, refer to the shop manual for corrective action. Once corrective action is taken, repeat the key on, engine off test procedure to be sure the problem is eliminated. This will be verified when you get a passing code 11. Once this is completed, continue the second phase of the diagnosis by performing the engine running test. After the self-test begins, resolve the service codes as we did earlier. Again, code 11 would indicate the MCU system is okay with one exception. That is, a drive complaint of detonation at wide open throttle and or poor performance on vehicles equipped with universal ignition modules having 3 connectors. This requires another test. On those vehicles with a knock sensor disconnected. Connect a timing light and verify ignition timing per information on the emission decal. Correct timing if necessary. After disconnecting the 2-wire module connector, use a jumper wire to connect the 2 male terminals that correspond with the yellow wire and the black-white wire. Again, check and note the timing. Then, after disconnecting the jumper wire, recheck to see if the timing retards between 16 and 20 degrees. If the timing does retard 16 to 20 degrees, reconnect the ignition module and set the high cam on the carburetor on the lowest step that will maintain an engine speed of 1200 RPM or greater. Remove and plug the vacuum hose from the zoned vacuum switches. Note the timing has retarded at least 5 degrees, which is correct. If timing had not retarded a minimum of 5 degrees, you would have a bad ignition module or defective circuit 324 in the MCU harness. If the vehicle is equipped with a knock sensor, reconnect the sensor and repeat the engine running functional test. At this time, however, do not tap on the sensor to simulate knock. If you receive a service code 25, the MCU system is okay and the test is completed. If any other service code is received during the engine running functional test, replace the knock sensor and retest the system. We haven't had time to cover all of the possible service codes, but if you know how to resolve one service code, the others will be easy. Just follow the service procedures in the flip chart or in the shop manual.
Servicing the MCU system is not a difficult task using the materials provided. Just give yourself a chance, and I'm sure you'll find that it's not the nightmare it appears to be. But if you do need help, seek assistance from your district office or service school.